Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and this lecture is entitled An Introduction to Indefinite Integrals. By way of introduction, so far in this course, yesterday, we've dealt with primarily finding f prime if we were given f. So we're changing f to f prime and applications of doing this. Today, we change and the question goes the other way. We start with a function, you can call it f prime, and we say let's find f and applications of this. Now it is important that you realize though that as you go forward in this course and the rest of your calculus training, you will have to do both of these. That means that your mathematical life is much richer, and I hope that in this mathematical life you are happily ever after. So let's begin with a question that actually will frame much of our discussion today. What function did we differentiate to get this function, x to the fourth plus 3x minus 9? Please spend some time on this. You know what to do. Let's see how you did. Now, like many questions in mathematics, there really is not just one answer. You could have had this one, where you have 1/5 x to the fifth plus 3 over 2 x squared minus 9x plus 10. Or you could have had the same polynomial, but instead of plus 10, it could have been minus 1954. Or you could have written this, where instead of minus 1954, the constant is 3,469 over 123. You see, any of those would work. In fact, the form of the answer is, it is a function capital F of x equal 1 over 5 x to the fifth plus 3 over 2 x squared minus 9x plus c, where c is any constant. That motivates the following definition. Given a function, lowercase f of x, an antiderivative of lowercase f of x is any function uppercase f of x, such that the derivative of uppercase f of x is equal to lowercase f of x. Yes, the upper and lower cases make a difference. And if capital F of x is any antiderivative of lowercase f of x, the most general antiderivative of lowercase f of x is called an indefinite integral and is denoted this way. And the way you will read this is the indefinite integral of lowercase f of x with respect to x is equal to capital F of x plus c, where c is any constant. In this definition, the stylized s is called the integral symbol. Lowercase f of x is called the integrand, x is called the integration variable, and the c is called the constant of integration. The process of finding the indefinite integral is called integration, or integrating f of x. And when we need to be specific, and we usually do, we say we are integrating f of x with respect to x. So here's a problem now posed in the new notation. Evaluate the following indefinite integral. So this is the indefinite integral of the indefinite integral of x to the fourth plus 3x minus 9 dx. You know what to do. Let's see how you did. And you see, this is the answer that you write. That's the same problem that we did before, but with the new notation. Now, some things to emphasize. Don't drop the dx. It's required. You should think of the integral sign and the dx as a set of parentheses. You already know and probably quite comfortable with the idea that every time you open a parenthesis, you must close it. With integrals, it's the same thing. The integral sign opens the parenthesis, says start integrating, and the dx closes the parenthesis saying stop integrating. If you drop the dx, it won't be clear where the integrand ends. And so look at these examples. We're putting the dx in different places, and we get different answers. So you only integrate what is between the integration sign and the dx. Another thing is, the variable we use really doesn't matter. It's just like solving an equation for x. If you write the same equation using the variable z, it's the same thing. It's a dummy variable. Here we also have dummy variables. So these three problems are all the same problem, but we use whatever variable we find the differential with respect to. We find that variable on the right-hand side. Finally, another use of the differential at the end of the integral tells us what variable we're integrating with respect to. Later on, this will be important to you if you take more calculus. So if we look at these two functions, here we're integrating with respect to x, and we're going to find later on that the answer to that is going to be x squared plus c. Here we have 2t dx. The t is not a function of x, it's a constant, and so here we get 2tx plus c. Very different answers. You see, it matters what we're integrating with respect to. We have properties of these indefinite integrals as well, and they follow from the fact that the derivative of a constant is a constant times the derivative. That means if we're integrating k times f of x dx, we can jerk the k through the integral sign, and it won't make any difference. And I will do this 10 times out of 10. And certainly that works for k being a minus 1. And moreover, since the derivative of the sum or difference is the sum or difference of the derivatives, when you go backwards, that means that the indefinite integral of the sum or difference of two functions is the sum or difference of their integrals. That means that you can do integrals term by term. Another thing that's true then, certainly if we take the indefinite integral of f prime of x dx, we will get f of x. Two things that are not true, and we saw that the derivative of the product is not the product of the derivative. Similarly, the indefinite integral of a product of two functions does not equal to the product of the integrals. And we also saw back in the derivative days that the derivative of a quotient is not the quotient of the derivatives. Similarly, the indefinite integral of a quotient does not equal the quotient of the indefinite integrals. So here's another problem for you. So if f prime is equal to this polynomial, that polynomial should look very familiar to you. What is f of x? You know what to do. Let's see how you did. And now you see that this is the answer in our new notation. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.